Let's get
Psycho.
Logical.
Psycho.
Logical.
Hi everybody and welcome to the channel. This is where we're going to talk about learning for the time being. And I know this is a time where we have many unknowns and many questions. How long is the lockdown going to last? What effect is it going to have on the economy? Is Dr. Daniel wearing pants? So with so many unknowns, I thought it would be useful for us to try to stick pretty close to the Domjan text so there won't be too many surprises coming from me. But that said, hopefully this will work out pretty well. And the first thing we need to talk about is chapter 6 in the Domjan text. And the overall theme of the chapter is schedules of reinforcement. So let me jump right in. One of the main goals of the field of learning is to predict and control behavior. In this section, we're going to explore a topic which we've learned a lot about, how patterns of behavior are determined by rewards in a given situation. And so armed with this knowledge, we can change the schedules of reinforcement in a given situation. And we can get more or less of the behavior that we want. And we can also use the schedules of reinforcement to predict things like how much time will an individual choose to do one behavior versus another. So that's kind of the overall flavor. It's about what kind of patterns of behavior emerge when you have different schedules of reinforcement. And that allows you to pick and choose the schedule that you want for a given situation. And what kind of choices do people make when there are multiple schedules of reinforcement going on at the same time? I guess I should say organisms. We are inclusive here of both humans and non-humans alike. Okay, so the first thing we have to define is, what is a schedule? And a schedule, very simply, is how and when rewards are delivered. Right? So we've talked a lot already about rewards and punishments and positive punishment, negative punishment, positive reinforcement, negative reinforcement, and that kind of thing. But now the shift is toward when and how often those rewards are being presented. So when we talk about schedules, we really talk about it in terms of two dimensions. Let me bring this here. The first dimension is whether the thing happens, whether the reward comes after an amount of time or after an amount of behavior. Right? So if something happens after a certain amount of behavior, so a certain number, let's say it's a rat in a box and he gets rewarded every fifth lever press, then that would be what we call a ratio schedule. So ratio. Or, alternatively, they could be on an interval schedule where on average about every 1 minute they get a reward. So that's ratio and interval. So that's one of the dimensions that we divide things into. The second dimension that we're going to divide into here is whether or not rewards are steady and happen on a fixed schedule, or whether they are intermittent. Right? Maybe they don't happen all the time. Maybe they happen on a variable schedule. Right? So let's look at these a little closer. We've got fixed intervals, variable intervals, fixed ratio, and variable ratio schedule. Right? And so we're going to walk through some examples of each of these and sort of talk about the different patterns of behavior that you get when you do each of these different reward schedules. Okay, so first, let's, I think the easier one to start with is the ratio schedule. So we're going to start there. And the first thing we can do is we can talk about what we call continuous reinforcement versus partial reinforcement. And continuous reinforcement is the bare bones, most basic example of reinforcement, which is every time you give, they exhibit the behavior, you give them a reward. In partial reinforcement, they're only rewarded on some portion of the trials. So let's say instead of giving my dog a treat every time he follows the command to sit, I give him one every third time that he sits, right? So 1 in 3 chance he's going to get a reward on any of the given sits. So that would be a partial reinforcement schedule. In that case, partial reinforcement, 33%. Okay, so we can have continuous or partial reinforcement on fixed ratio schedules. Okay, the next thing we should talk about is what difference does it make whether the schedule is fixed or variable? And at first glance, it doesn't seem like it should make much difference. Right? But in fact, and why wouldn't it make much difference? Well, because they're both getting rewarded the same amount over time. And so what difference would it make whether it's happening on a fixed schedule versus a variable schedule? But here's what happens. So when you're on a fixed ratio schedule, so that means that every time you exhibit a certain number of behaviors, you get a reward. So maybe every time, hopefully, you put in your money into the machine and push the button, your beverage of choice falls out the bottom, right? And we get very upset if that isn't the case. So that would be a fixed ratio schedule, continuously reinforced. And that would be what we call an FR1. FR1. Example, Coke machine. All right. Maybe you had a chore chart when you were a kid, and so maybe this is on an FR7. Every day you get a little sticker. You put the sticker on the chart if you do your chores, and at the end of the week, on the 7th day, if you did your chores every day that week, you'd get a little prize. You could get to go get ice cream or something, right? That would be a fixed ratio 7 because it's 7 behaviors that you have to do, and then you get a reward. Okay, now, when the chore chart's kind of an interesting example because I guess it's a sort of a bad example for what I'm trying to illustrate, because typically you get you only have the opportunity to earn the reward once per day, and that sort of changes the dynamics of what you see. Typically what you see when you see a fixed ratio schedule is you see what we call a run of behavior followed by a post-reinforcement pause. Okay, so let's say this is behavior over time. So I'm just going to draw a graph here. And on the left side, I'm just going to write number of responses. And we're just going to count the grand total number of responses over time as they add up. So I'm going to start with no responses, so it's down here at 0, and then let's say we get a response. We're going to just go up just a tick. Right? I'm going to draw it over here a little bigger, same thing, but I'm going to draw it, so this is behavior happening, pretend this is at 0, and then we have a 1, 2, 3, so we can graph it. So when the first response happens, we're just going to move up 1 tick. And then we're going to keep happening. And on this x-axis, this is just time moving forward. Okay. And then let's say sometime later, another response happens. Oh, and then shortly after that response was yet another response. And then they take a break for a while. So what we get is we get this kind of stair-step pattern. Originally, when they were recording one of the most early Skinner boxes, when they would record the behavior, this is how they would do it. They would have a little roll of paper that would be slowly unrolling past a needle with a nib on it that had, or a pen that had a nib on it, sort of like a polygraph test. If you've seen a polygraph test where the old school, where the paper kind of rolls out and the needles kind of jump around. Well, that's exactly what was happening here. The needles would, whenever the animal would make a response, the needle would jump up 1 notch, and the paper would unroll some more at a steady rate, and then the next response, it would move just a little bit more, and then a little bit more, and a little bit more, and you would get this sort of stair-step pattern over time. Now, of course, when you zoom out, and the way it would really look is because these were really small increments in change, you would get this kind of rate of, it would be a stair step, but it'd be just kind of a squiggly line, and you could see different patterns start to emerge. Now this is called a cumulative record, and it's recorded by an instrument called a cumulative recorder. And on a cumulative record, the slope of the line tells you the overall rate of behavior. So if they're behaving a lot, like let's take this little chunk where we have a really steep slope in the graph. If you look, see we go up a lot in a very short period of time. Well, that would be when they're really banging on the lever, right? Bang, 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 bang. Right, making that lever go, the needle go up, 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 up. Okay, so that's a high rate of responding, and then you can see afterwards there was kind of a flat area in my made-up data set where there wasn't a lot of activity. Okay, so when you look at a cumulative record made by a cumulative recorder, what you see is a kind of squiggly line that's getting bigger and bigger and bigger, and going up, 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 up. And what happens when it gets up to the top? Well, these days the top doesn't exist because we do it electronically. But at that time, what would happen is it would sort of reset like an old typewriter or a record player or something. It would go straight back to the beginning and start all over again at the bottom of the paper roll. Okay, so the cool thing about these, by the way, is that you get all the information that you would get from a bar graph, say, of the rate of responding, but it also includes the actual raw data here. And so this is kind of a nice way of representing the data because you can see all of the data, not just an average summary of what happened. You can see the whole thing right there on the page. So I think these need to be more popular than they are, and there are some other kinds of graphs that are kind of, I would say, related to these that might be and they need to catch on because they have some benefits. They include all of the data. There's a big trend right now for journals to start asking people to include plots of raw data on the graph. And so what do? They put a bar graph in the paper, and then they plot the individual data points as dots around the bar, which to me is kind of ugly. It looks like the bar has some sort of disease or something. And so this is a much more elegant way to plot raw data. So I like it. Anyway, every lever press, every key peck is there. Okay, so now that we know what we're looking for here, let's go back to our original example that we were working on. And what happens is when you have a fixed ratio schedule, what happens is, so let's say you get 10 cents, or you get paid $1 for every 10 widgets you make. Right? Well, what tends to happen is people will work very rapidly until they get that reinforcement. And once they get the reinforcement, then the behavior flattens off for some period of time. And that period of time where it flattens off, we have a word for it, of course, because this is what we do. We label these kinds of things. This is called the post-reinforcement pause, or the PRP, post-reinforcement pause. And then there will be another run of behavior, where they go up, and then another post-reinforcement pause, and then up, and a post-reinforcement pause. So what you get is this sort of stair-stepping sequence of runs and pauses with a fixed ratio schedule. Right? So people will work real hard, get the reward, and then it's like, well, I need a break. And in some cases, that might be what you're going for. Right? In other cases, that might not be what you're going for. So maybe if I'm the boss and I know that my transcriptionist gets paid for every page that they type, then and I notice that they type a page and then they take a break, and then they type a page and then they go smoke a cigarette, and then they type another page and then they go to the bathroom, and then they type a page, and constantly they're doing these little post-reinforcement pauses. If I'm the boss, I might be thinking, man, we're really wasting a lot of time here where I'm paying them for these pauses. And so maybe I want to do something different. Right? So the pattern of behavior you get on a fixed ratio schedule, very predictable. Okay. One other thing we can talk about with a couple things we can talk about with the fixed ratio. Let's talk about something called ratio strain. Ratio strain. Right. So imagine you're shaping some behavior where you're starting an individual off at every page they get a little reward. So every page you write, let's say you're a writer, and your editor says, okay, every page you write, we're going to pay you $20. All right. So you start writing pages and getting rewards. And now the editor switches and they say, we're going to change your pay schedule. We're going to still pay you the same amount, but instead of paying you every page, we're going to start paying you by every book that you write. Okay? So if you'll write a book for us, then we'll pay you. And it'll be, the book has to be at least 300 pages. and we'll pay you $20 a page, 300 pages. So what's that? $6,000. So we'll pay you that much for your book. And what do you think the chances are they're gonna get that book written anytime soon? This is what's called ratio strain. This is when you increase the required ratio too much at one time, and that can increase the post-reinforcement pauses. So instead of working on it, get a reinforcement, take a break, what happens is you just wind up you go, you increase it enough. If you increase it too much, they work for a while, and then they just sort of quit, and they just kind of hang out, and they never respond again, or they respond really slowly. And so this is what we call ratio strain. You're straining the limits of what the ratio schedule can handle. So what do you do instead? You can use what we call a progressive ratio instead, right? And this is sort of like the analogy of boiling the frog, right? Where you take you slowly introduce them. It's sort of like a shaping of behavior. You slowly introduce them to the schedule. So maybe you start off with an FR1. So every time they do the behavior, they get rewarded. And then you shift to an FR2. And then maybe they move to an FR5 and an FR8. And instead of going from 1 straight to 8, you gradually increase it over time. That's called a progressive ratio, because you're gradually progressing in a direction. Another thing you can do, interestingly enough, that they do with progressive ratios, is if you keep the reward constant, you can keep doing this until they stop responding to the reward altogether. And you can use that as an index of how much they actually value the reward. So how much is one food pellet worth? Well, it might be worth 1 lever press or 2 lever presses, but it might not be worth 1,000 lever presses for 1 pellet. It just might not be worth it. So you figure out, well, what point did they stop doing this? And that tells you how valuable, in terms of that behavior that's required, the reward is. Kind of an interesting thing to do. And that way you can compare. Let's say you wanted to compare how much your kid likes M&Ms versus how much they like time playing on a tablet. Now those are two completely different rewards, but so it's really hard to compare them. It's not like you're comparing $1 to $2 or 2 M&Ms to 5 M&Ms. You're comparing two completely different things. But by using the behavior, you can figure out, well, how much work are they willing to do for a couple M&Ms? How much work are they willing to do for screen time? And that will tell you the relative values of those two activities, even though they're very different values. So this is kind of a useful idea, this progressive ratio thing. I don't think the book talks about that, but I figured I'd mention it because I think it's kind of cool. Let's see. Okay, so that's the introduction to fixed ratios in a nutshell. Now let's move on to variable ratios. Variable ratios. So instead of a fixed response, 1, 2, 5, etc., maybe we do a variable ratio 5. Right? And that would be like something like every 5th time you press the lever, on average, you might get a reward. Right? So there might be sometimes you would press the lever and you might get the reward. The next trial, you might press the lever again, and you might get another reward right away. Right? You might get 2 in a row. That would be really cool. Other times, you might press the lever 10 times in a row and not get anything. And but on average, if you looked at it over the long run, the rewards are happening on average every 5th trial in a VR5, or every 5th response, I guess I should say. So a great example of this would be something, it'd have to be more than 5, let's say 500. I don't know, we can reduce it actually, because I'm thinking about going to Vegas, you know. Maybe when this whole thing blows over, we can go have some fun in Vegas. VR, let's say VR, maybe 5 is better. Let's go 10. Let's say 10. Let's say our machine pays out something every 10th spin. The casinos want to keep you there, so you need to win a little bit every now and again. And so you go to the one-armed bandit, the slot machine, and you start putting in money, and ka-chunk, 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 you're getting the you're spinning those wheels, and on average the machine pays out every 10th pull of the arm, right? And you know, so that means you might pull twice in a row, and you might win. You might win 2 jackpots in a row if you're crazy lucky. Probability of that is very low, obviously, but you might win a jackpot, pull a lever again, immediately another jackpot. On the other hand, you might pull the lever, 30, 40, 100 times. They're just taking your money, and you get nothing, right? It's unpredictable. There's uncertainty there. And so that's how variable ratios work. Variable ratios are unpredictable. So let me put the slot machine here as the example. And they, much like a fixed ratio, result in a very different and unique pattern of behavior. And the pattern of behavior that you get there, if you look at responses over time, is you get a very rapid and steady rate of behavior, right? There really aren't very many. I accidentally drew it like as though there are some post-reinforcement pauses here, but basically you get a high and steady rate of behavior. That's why slot machines use it. Slot machines don't want you to win big, like play 8 slots, win big, and then take a break, go home. They want you to stay there the whole time because you never know when the next one's going to come, and so you keep, right? You keep responding. So slot machines are designed with variable ratio schedules in mind. The more you play, the more chances you have to win, but you never know when the next reinforcement is coming. You might notice that there are a lot of video games. Oh my God, especially on mobile games. So if you look at some of these mobile games that have random components in them, where you spin a wheel, or you open a treasure chest, or you do something each day, or with some regularity, those are basically virtual slot machines, and they not only are they fun and reinforcing, they make a lot of money. So free games, if you look at the free games, the top free games, things like Clash of Clans and Candy Crush is huge. One of the highest grossing video games of all time. And it's a free game. But people want to keep making that. They're getting those little shots of dopamine, that little reward over and over again. And so they want to keep responding. And so when they get to the point where you need to wait some time. Oh, that's not going to do. So what do? They start dumping money into them, right? Some people dump a lot of money into them, and in the video game industry, they call those people whales because they're the ones. It's a tiny fraction of the player base, but they support the game for pretty much the rest of the people playing for free. So I would be interested in a study that looked at video game whales, if we could figure out who they are, and figure out, what are they like? What makes them more susceptible to, or more willing to hand over their money for the opportunities to do more responding on these kinds of schedules? It'd be kind of interesting. All right. Okay, so now that we've talked a little bit about ratio schedules, let's shift to variable schedules. Let's talk about interval schedules. So I'm going to make a little new space over here. And let's see, interval schedules. One of the things that interval schedules do, so this is where you get instead of getting rewards after a fixed or variable number of responses, you get rewards after a fixed or variable interval of time. And so one of the key features of an interval schedule is it measures the organism's ability to tell time. So how much time has elapsed? That's going to be one of the key things we are measuring when we look at interval schedules. So it's no surprise that many studies that or that look at timing employ interval schedules. So let's say let's take an interval schedule. We're going to do a fixed interval 1 minute. All right. So that'd be an FI 1 minute. That would be something that happens once a minute. Once a minute, the reward becomes available. So when you think about this, you have to think about there's a feeder in the Skinner box. Right, I'm drawing the front wall of the Skinner box, and here's a little hole, and let's put a little key light here somewhere in the box. And what happens is after 1 minute, this feeder becomes armed such that the next peck on this key light or press on the lever or whatever it is going to result in a reward. Right? So it doesn't matter once this thing is armed. Right? It doesn't matter if you get there exactly at 1 minute. The next peck or press after 1 minute is going to be the one. So let me give you an example of a fixed interval schedule. My mail carrier comes by at the same time every day, and sometimes I see her out there at about 2 o'clock. But let's say I don't have a clock in front of me, and I don't know what time it is, and I think, I'd like to go check the mail. It doesn't make sense if I checked the mail 5 minutes ago to go back and check the mail again right away. Instead, what makes sense is for me to wait until I'm pretty sure that the mail is there, and then go get the mail. And so I don't go back 5 minutes later. I don't go back 2 hours later. I wait until about the right time of day the next day. Even if I don't have a clock, I can estimate it. And it doesn't matter, if I get there early, nothing bad really happens, but there's no point in getting there early, right? But the mail is going to be in the slot the minute it's available. So that's equivalent to arming a feeder, for example, is that the mail is there, and any time after, let's say that my mail carrier comes at 2:36 p.m. Any time after 2:36 p.m., if I go to the mail slot on that day, then I'm going to be rewarded with my mail. If I get there early, then I'm not going to get anything. Right? Well, that's how this works. So at a fixed interval 1 minute, that means the organism has to wait 1 minute, and then the next response after that minute has passed will be rewarded. And this schedule results in kind of an interesting pattern of behavior. Whereas in the fixed ratio, we got these patterns of steep rises, right? Steep runs of behavior, and then a flat post-reinforcement pause, and then a steep run, right? In in a fixed interval, something kind of different happens. So what happens is, let's say I'm going to tick off the intervals here, right? So what happens is nothing happens for a while, and then you get a gradual, usually the rule of thumb is about halfway through the interval, depending on how good the animal or person is at timing. Going through this interval, about halfway through, they start to respond, make a few responses here and there. But then it doesn't really pick up. But as you get closer and closer to the end of the interval, it really shoots up there. So let's say this is the beginning, and then, right? So these responses are going up, 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 up. So then bop, 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 bop. Right? And then they get the reward, and we get a post-reinforcement pause. And then about halfway through that interval again, bop, 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 and we get a post-reinforcement pause. And what you wind up with is this kind of these semicircle patterns, right? This kind of scoop, right? Instead of kind of stair steps like you saw with the fixed ratio, you get this kind of scooping pattern. And we call this a scallop pattern, the FI scallop. It's named after the animal because of the shape of the shells on the scallop. So yeah, this is called the FI scallop. A very distinctive pattern that shows up in the cumulative record. Again, this signifies when the food is available, not when it's received. So it might be the case that they might be going along and doing nothing, make a few responses, and then the feeder might be armed, let's say at this time, but they don't make another response until a few seconds later, right? That's when they're going to get rewarded, right? So it's not strictly that they get the reward every minute, it's that they have the opportunity to get the reward every minute. Now you might notice that tests in courses, college courses, tend to follow a fixed interval pattern. And likewise, they tend to generate a post-reinforcement pause. Now, as an instructor, this looks to me like the enemy, because I would rather you had a steady rate of behavior throughout the interval. I want you to have a habit of studying every night, every day, right? So have a routine. I don't want you to cram right before the test, and then not think about it again until right before the next test, right? No, I want you to be studying over time, and the reason why is because evidence shows that that's a better, more effective study strategy. Okay, so what's the solution? How do I take this nice FI scallop and turn it into a steady rate of behavior? Right. Well, what you can do is you can make it a variable interval. Right? So imagine that instead of me scheduling the tests in advance, roughly every 4 to 5 weeks, what if instead I said, you don't know when it's going to be, but on average, there'll be a test every 4 to 5 weeks. You might come in one day and have a test, and then you might come in the next day and have another test. And I could make it truly unpredictable. And what would happen to your pattern of behavior? Well, you would tend to study in a more steady pattern. And then we would have reinforcers happening occasionally. So in this way, something like a pop quiz would be better, because pop quizzes happen on a variable interval schedule. Now, I'm not a Dark Lord of the Sith, not yet anyway, and so making regular exams completely random and unpredictable, I think, is just a little bit too evil, but it sure does give you this type of behavior that you want, if your goal is getting a steady rate of behavior. Okay, so what happens? Let me come back to me here for a moment. Let's chat for a moment. Serious talk. What happens if when you have a VI schedule that delivers rewards at the same rate as a VR schedule? So we're going to have variable schedules, but what difference does it make whether it's interval or ratio? Because remember, both the variable ratio and the variable interval, both of them are unpredictable. Both of them result in steady rates of behavior, kind of moving steadily up. And so what difference does it make whether things happen on a variable ratio schedule or a variable interval schedule? Right? You still never know which response is going to be the next one that's rewarded. So it seems like, on the surface at least, it shouldn't make any difference which schedule you're on, because sometimes you pack and you get a reward, and sometimes you don't. Okay, so how can we pit this against each other? Well, there's a really clever experiment, which is, these are the kinds of things learning people love, is designing clever experiments. The big problem is, how do you make sure that if you wanted to compare a VR schedule and a VI schedule, how do you make sure that two animals get the reward at the same time? So I want to walk you through this little experiment, and this is by Reynolds, 1975, and the book talks about this experiment as well. And so let's see, Reynolds. (1975). And what we're going to do is we're going to have two Skinner boxes here. And I'm going to indicate the responses of the birds by little hash marks here, just to kind of cross off behavior. But picture in each of these boxes, we've got a front wall with a feeder and a little key light that when the pigeon pecks the key light, it's going to get rewarded on some schedule. Okay, so we need a couple of pigeons, and you're going to love this. First, we have, now of course we're going to do two groups of pigeons, but just to, we're going to have Pip as our example bird from group 1, and we're going to have Cooper as our example bird from group 2. So we got Pip and Cooper here, both in their Skinner boxes next to each other, waiting to make responses. Oh, watch out, Cooper! There, don't respond yet. We haven't started yet. Okay, so Pip and Cooper. So Pip is going to get a VR schedule, and Cooper is going to get the variable interval schedule. Right? So how do we make sure that if they're on two different schedules, that they both get rewards at roughly the same time and roughly the same number of rewards and all that stuff, when this one has control over their behavior, and this one, the more he pecks, the more rewards he's going to get. This one, he has no control over it, because the more he pecks doesn't matter, because this feeder is only going to become armed after a certain amount of time. Okay, so so Pip on the VR schedule here's what they do. Okay. So Pip gets this VR schedule based on the number of responses that they have. So let's say it's a VR 20. Every 20 pecks, peck, 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 some food gets delivered. Right? So let's say VR 20. Okay. Actually, just to make it easier for me to draw, I'm going to say it's a VR 5 because otherwise I'm going to be drawing tick marks forever. Okay, so we're going to say it's a VR 5 schedule. So what's going to happen here is Pip is going to be making his responses. Cooper here is going to be yoked. So Cooper is going to be yoked so that when Pip gets to be one response away from reinforcement, we're going to arm Cooper's feeder so his next peck is also rewarded. Right? So let's say we've got Cooper around here. You know, let's have Cooper and Pip both doing their thing. And peck, Pip did a peck, so we're going to draw a mark. Cooper is just hanging out. Pip does another peck, second peck. Okay, that's Pip, peck 2. Cooper does a peck. Okay, so we got a peck here. Pip does another peck. No rewards so far. Cooper does a peck. Okay. Now, Pip does a peck. Okay, now keep in mind, at this point, the very next peck that Pip makes is going to result in a reward. So therefore, you can consider his feeder is now armed. So what do we do? Because the next peck will result in reward. What do we do? At this point, once Pip has made 4 responses of the 5 he needs, we go ahead and we say, okay, we're gonna arm Cooper's feeder as well. So that means the very next peck that either bird makes is going to be rewarded. Right? So Pip makes his peck, Cooper makes his peck. Don't know who's going to go first, but the very next one that gets rewarded, right? They get fed. I should have made little food pellets. But, all right, so you get the idea. We don't know exactly what the interval is that Cooper is being trained on. We could go back and calculate it later. But it's really dependent on his friend Pip's behavior. Because the faster Pip pecks, the more rewards that Cooper's going to have the chance of getting as well. Okay, so what happens when you do this experiment? Let's see the results of this experiment. What do they look like? Before we look at the results, notice that the birds are getting reinforced at basically the same time. One's on a VR schedule, one's on a VI schedule. They have the exact same number of rewards happening at the exact same frequency. Shouldn't their behavior be the same too? Getting the same number of rewards, happening at the same frequency. Why would their behavior be any different? Well, in reality, if you look at Pip's group, right? So this is responses over time. Pip's group was responding fairly steadily, like crazy. Right? And so they would get rewards now and again. And they responded at a steady rate. Let me draw these reinforcer lines there. Okay, what about Cooper? Well, so that's the variable ratio. Turns out the variable interval was steady behavior, but overall the behavior was the rate of behavior was lower. Okay. That's weird. So they got the exact same rewards at the exact same times, but for one of them they were responding a whole bunch, and for the other one they weren't responding so much. Steady, but not as much. let's just say he had a little more room to rev up the gas pedal there. Cooper did. All right. So you can think about it this way: the rewards may have been the same, but the behavior being rewarded was different. Pip was being rewarded for more pecks, whereas Cooper wasn't. Right? So Pip, the more pecks he does, the more rewards he's going to get. For Cooper, it doesn't really matter how much he pecks. As long as he checks in now and again, he's going to get the reward roughly at the same time. Now, this has been replicated with humans. The details of those kinds of experiments, I think the book has a couple of examples. But think of the implications if you're an employer, that you could get this higher response rates for the exact same pay. These birds are getting the exact same rewards, the exact same pay, but one of them's dramatically responding more. And that's what happens if you base the pay on the number of tasks performed as opposed to, say, an hourly wage. Right? So if I was an employee, I would be saying, maybe these hourly wages are a good thing because I don't have to work so hard. But on the other hand, if you pay by the number of tasks performed, so for example, if you're a transcriptionist, medical transcriptionist, say, who gets paid by the line, 5 cents a line or something. I don't know how much they get paid these days. But if you were doing a job like that, you're going to be working way harder than if you were doing the same job for the same amount of pay overall, but not based on the number of lines that you type. So same pay, but one gives you way more rewards or way more behavior than the other. Okay, so this little phenomenon has generated a lot of research to try and understand it, explain it, and I want to give you just two examples of that, and then we'll call it quits on this video. But let's look at two possible explanations. These are not the only two explanations that might be out there, but these are two that have been used. And I mainly want to give you this idea because it introduces the idea of something called a feedback function, which I think is kind of cool. All right. So the first explanation is that the first explanation focuses on what's happening as the animal is behaving, right? And so the first explanation looks at the inter-response times, or IRTs. So if we look at what Pip was doing on his VR schedule, he was being rewarded for pecking a lot. Right? The more he pecked, the more rewards he got. And so the time between each of his responses was small. So small IRTs, inter-response times, were reinforced for the VR schedule, but not in exactly the opposite is true in the VI schedule, because you don't want to be pecking away for nothing, right? There's no point in pecking. There's no point in me going to that mailbox over and over and over again throughout the day. I'm not going to get any mail until the mail arrives. Until that feeder's arm, there's no point in pecking at that thing. So what are you rewarding? You're rewarding long inter-response times in the VI schedule. So it's exactly the opposite. So that's one explanation that's been put out there, and that one just makes a heck of a lot of sense to me. I like that idea a lot. The other one is that the animal could be using what we call a feedback function. And the idea behind a feedback function is that it doesn't just look at the things that happen right before the reward, but it looks at the overall reinforcement rate and the response rates across the entire experimental session. Right? So it doesn't look at what the animal's doing. Is it pecking really really fast, and it gets a reward. That's a more molecular kind of analysis. We'll use that word molecular to describe it, as opposed to molar. I don't know if you had a chemistry class, but in chemistry class they talk about molecules, but then they talk about moles of molecules, which is a mole is a whole bunch of molecules kind of put together. So this interresponse time, that's kind of a molecular analysis. The feedback function is what we're going to call a molar analysis, where it looks at the big picture, zoom out, look at how many responses did they get, how many responses did they make over the entire session versus how many rewards did they get over the entire session. Now think about the feedback function for a VR schedule. How many responses can they make, and how many rewards can they get? Right? Feedback is about rewards. So how many rewards can you get in an experimental session on a VR schedule? Well, there's no limit. The only limit is how fast you can peck your little beak on the key, right? The only limit how much you can get paid as a medical transcriptionist, being paid by the line, is to type. How many lines can you type, right? Type as many lines as you can, and that's going to be the upper limit. So in theory, there is no limit. If you could figure out a way to type faster, you're going to get more rewards across the entire session. On the other hand, in that case, the session is a work day. What about for the VI schedule? You're going to get rewarded. Let's say you're getting paid by the hour. How many hours can you get paid in a day? Well, presumably for most people it's probably 8. If you're lucky enough to have the opportunity to get overtime, you might do a little better than that, but I can guarantee you there's an upper limit of at least 24. You can't get more than 24 hours of pay in a day, right? So, feedback has a limit. So maybe what they're doing is they're not paying attention to what's happening at the moment they're being reinforced. Maybe what they're doing is they're just sort of tracking their overall rewards over time, and they're figuring out, well, in the case of the feedback function for the VR animal, they're like, wow, there's no limit. If I just work harder, I can get more rewards. But for the one on the VI, they say, well, don't bother because there's only so many rewards you can get. So just do the minimum effort to get those rewards, and then you're golden. Another way to think about this is fishing. I don't know if we have any fisher people in our group, but if you go fishing with a pole, I'm not talking about with like a net in the ocean. I haven't done that, but I've seen it on TV, and it looks like a nightmare to me. It's incredibly dangerous. But I mean like with a pole and a worm or a fake worm or whatever you like to put, hot dogs, corn, whatever you like to put on your hook. toss that thing out in the water, and the reality is fish are only going to bite so often, right? So even if I stay out all day, I may only catch a few fish. They're going to be biting at a variable interval, right? And it doesn't matter. I can't, I cast my line in the water. It doesn't pay for me to immediately just start reeling it back in and cast it again and reel it again and cast it again and reel it again and cast it again. What matters is I need to just be spending more time in the water. So casting like crazy is just going to wind up with me with a bobber stuck in the tree or something. In that case, the feedback function for fish biting is going to have a limit. Okay, so let me refocus here. That is kind of the introduction to this section on schedules of reinforcement and how we can predict behavior based on the schedules in a given situation. We know what the pattern of behavior is likely to look like, and we know something about how these things are kind of related to each other. So I encourage you to think of other examples on your own of each kind of schedule and try to apply this to other situations. Think about what are some situations where you have post-reinforcement pauses in your life. And maybe those are good things, maybe those are bad things, right? So maybe you go to the gym. That's a bad example right now because we can't go to the gym. But let's say you go to the gym and then you think, boy, I worked out really good. I should take a break for a while. Maybe you want to have a steady rate of behavior. How can you do it how can you adjust the situation so that you get the pattern of behavior that you want in yourself? Or maybe you're thinking, geez, I'm working too hard on this thing. Maybe you could shift the reinforcement schedule away from, say, a VR schedule to a VI schedule. All right, that's all for now. In the next video, we're going to be talking about choice behavior. What happens when you have two different schedules happening at the same time? Often choices don't happen, or behavior doesn't happen in a vacuum. There are other things happening around, other different sources of reinforcement, and you're going to want to be able to make choices. So how does that work? That's what we'll talk about next time. All right, see you later.